Hello everyone, this is a video for Calculus 1. The topic for this video is going to be an introduction to implicit differentiation. We're going to go over some notation and a couple of examples, the last one with finding the slope of tangent lines to a point. Alright, let's get started. Now to start off, there's a few different notations that we often see. We see y prime or dy over dx. Now, we've seen a lot of differentiation where we've had d over dx. What makes implicit differentiation different is that we do the derivative for x as well as we kind of incorporate a derivative for y. And we have to use some specific notation to kind of keep track of that. And the trick for this is anytime you have a y, let's say it was 3y squared, you add this, either one of these notations, this y prime is what it's called, or dy dx, whenever you take the derivative with a y. So for here, for this 3y squared, we would bring the power rule down and differentiate like normal. So this would be 6y, because 2 minus 1 is 1. And then we write in y prime, or we can write 6y dy dx. Now they mean the same thing, so I'll try and use both of them as we go through the examples. So we're going to start off with two fairly simple examples. The first one is a x squared plus y squared equals 1, and that's just our unit circle pretty much, right? And the instructions say to find dy dx of x of this equation. So we do step by step, and so we take x squared, the derivative of that is 2x. Now for this, the derivative of y squared, we do y, so we plus the derivative of y squared, which is 2y, and then we add on dy dx. And then next we have the derivative of a constant, which is 0. So now what we're going to try and do is we need to isolate this dy dx and get it kind of by itself. So what we can do is we can subtract 2x from each side, which gives us 2y dy dx equals negative 2x. The next step that we can do is we divide by 2y each side, and we're left with that dy over dx equals negative xy. And that is implicit differentiation to find the derivative of x in relation to y, or y, sorry, y in relation to x, of the formula for a circle. And at that point, you can use different points along the circle, our unit circle, and put in our x and our y's to get the slope at that point. So our next example is a little bit more complicated. It's find y prime of x. Remember, y prime and dy dx are similar notations. And the equation is sine xy equals x squared plus y. So we're going to break this down piece by piece. And here we've got an outer function and an inner function. So let's do the outer function first. The derivative of sine is cosine, and the inside stays the same. But then we multiply, right, by the derivative of the inside. Now we have xy. If we take the first, x, the derivative of the second, which is y prime, plus y, the derivative of the second derivative of the first, which is y, and the derivative of x is 1. And we're going to keep going, and we've got x squared, the derivative of x squared is 2x, and plus y, the derivative of 1y is just y, but remember we've got this y prime that goes in. Now we have something interesting going on. We've got a y prime here and a y prime here. And what we need to do is we need to get all the y primes on one side and everything else on the other. Because then once we get all the y primes on one side, we factor out a y prime. And we can solve for that. So let's start doing this. So if we distribute this cosine xy to each term, right, we've got cosine xy and then times xy prime plus cosine xy y. Just for notation, I'm going to bring, when I rewrite, I bring these out in front so it's a little easier to see, equals 2x plus y prime. Now what I'm going to do is I'm going to subtract y prime from each side. And I'm also going to subtract y cosine xy from each side. So let's rewrite this a little bit nicer, a little bit cleaner. So this x y prime cosine xy and minus y prime equals 2x, and remember we've subtracted y cosine xy from each side. So we're getting close. Let's see what we can pull out. We've got y prime here and y prime here. So let's factor that out of each and see what we get. So we get y prime times x cosine of xy minus 1 equals 2x minus y cosine xy. And now we've got y prime times something. And what we can do is we can actually just divide each side by that something. And in this case, it's x cosine xy minus 1 for each side. So x cosine xy minus 1. Now in this instance, there isn't anything we can simplify, so we get y prime equals 2x minus y cosine xy, all that entire quantity divided by x cosine xy minus 1. Now we got both of these answered by following just a few steps, where we took, each time we took a derivative of something that included y, we either included dy dx or y prime, either notation. And then the first one, it was pretty straightforward. The second one, we had to do some rearranging where we got this y prime, all the terms with y prime on one side, and then factored it out. All right, on to the next. All right, for the last example for this video, we're going to talk through and work through the steps of finding equations of tangent lines at a point. And we're going to use two steps to do that. The first is we find the derivative, which gives us the slope at that point. And then we use good old algebra, y minus y1 equals m times the quantity x minus x1 to find that equation. So let's get to work. The first thing that we do is we copy the equation. The equation that we're given is x squared plus x times y minus 3, or y cubed, equals 7. And because we've got x and y's that can't be separated, we're going to use implicit differentiation. And whenever we take something with the derivative of y, we include that y prime. So first let's take the derivative of x squared, which is 2x, plus the derivative of x, y. We have that product rule. where we take the original, which is x, times the derivative of the second, which is y prime, plus the derivative of the original, or the first, which is 1, and then the second term. So all of that is our product rule. And then the last thing on the left side is we've got minus y cubed. If we take the derivative of that, that's 3 minus 3y squared. And the derivative of a constant is just 0. Now, how do we get everything on one side? Oop, y prime. Can't forget that y prime there. So what I'm going to do is I'm going to say, okay, we have a y prime here and a y prime here. Let's move those to the other side. So we're going to add 3y squared y prime and subtract x y prime. So we'll rewrite everything. That 2x stayed on the left side, and then plus y stays on the left side. Over here we have 3y squared y prime minus x y prime. And we can factor out a y prime from each term. So let's do that. We have 2x plus y on the left. Factoring out a y prime, we have y prime equals 3, or y prime, not equals, times the quantity, 3y squared minus x. Now to solve for y prime, we just divide each side by 3y squared minus x. And that gives us our final answer for the derivative of y prime being 2x plus y over 3y squared minus x. All right, so we've got the derivative. Now let's find the slope at that point. We do that by taking our x and our y from the original point. So y prime equals, our x is 3, our y is 2, 2 times 3 plus 2, all over 3 times 2 squared minus 3. Now 2 times 3 is 6, plus 2 gives us 8, and then 2 times 2 is 4 squared, 4 times 3 is 12, 12 minus 3 is 9. That's our derivative, or our slope, at that point. So we're almost done with finding the equation of this line. And what we do is we take, let's use red. We get y minus our y1, which is 2, equals 8 over 9, because that's our m, times x minus 3. And we solve for the equation. So the first thing that we'll do is we'll distribute this 8/9 to everything. So we've got y minus 2 equals 8/9 x minus 3 times 8 over 9. Now we can do a little cancellation here, so that gives us 8 over 3. And we've got y minus 2, but let's add 2 to each side, but we're going to make 2 look a little differently because we need a base of 3, or a denominator of 3. So if we add 6 over 3, we're adding 2 to each side, and that gives us y equals our slope of 8/9 x. And then if we add 6 over 3, then minus 8 over 3, that gives us minus 2 over 3. And that is the equation of the tangent line at that point. We did that by finding the derivative, using the values to plugging those values of the point into the derivative, and then using what we know as the derivative of the slope and the formula y minus y1 times m times quantity x minus x1. Hope this was helpful. Have a great day.